Okay. In the hope it works now, we are live on YouTube for our 29th Everyone Can Contribute coffee chat or cafe. And today, David joins us from Puppet and we'll be talking about operational verification. Not sure what that is, but we will totally learn it now. So, David, it's your stage. Go ahead.
Thank you.
Surprise us.
Thank you. Let's start by sharing my screen. I've got some slides prepared. Good afternoon, folks. Operational verification is something that I'm currently working at Puppet, starting out with a new module to provide more confidence in your infrastructure's health. Right. Well, I hope I don't need to convince you that having confidence in your deployments is necessary. I hope to show today that it's possible to improve on the situation that we currently have. First, a few words about words. Like what am I even talking about? Here is how I learned them in university an eternity ago, where verification is process-oriented. Are we doing the things in the right way? Does each step match the requirements? So a very detail-oriented view of are we doing the things in the correct way? On the other side, we have validation that is outcome-oriented. Are we solving the actual problem? Are we helping customers to move forward with their services? Are we doing the things that business actually needs? Right? In refreshing my memory on these distinctions, I found a very good blog post by a computer science professor who summarizes it as verification will help to determine whether the software is of high quality, but it will not ensure that the system is useful. Right? He also goes on to say that this is a very strict distinction that's not necessarily useful for practitioners. And he shows this graphic here on the slide. It's from the same blog post, and it shows various techniques that we can apply throughout the software lifecycle to ensure that the solution is within the specification, but also that the specification is actually something that solves the customer's problem. It's not a binary, really. It's a whole set of actions that we take along the process to be sure that we are on the right track and the track is leading in the right direction. So on the validation side, you can see things like goal analysis, prototyping, and customer testing to get feedback from the customer or from the business that something is produced for, to understand that everything is going in the right direction. On the verification side, on the other hand, we have automated tests, code analysis, static analysis, things, again, more process-oriented that help us understanding that we are meeting our code standards, that we are still solving the problem that we have verified is the problem that the customer needs solved, etc., etc. In the Puppet ecosystem, on the verification side, we have unit and expectation tests that are responsible to check either low-level expectations on the Puppet code itself, or higher-level system tests that verify that a specific piece of Puppet code applies and does the right thing. Right? These are, again, verification steps that check the code against a often hand-coded specification of the test cases that we put into the code. While these tests never will be able to judge the ultimate purpose of your service, right? Like a hand-coded test can always only be verification and not validate against customer requirements. There is a clear progression in the testing scope as the tests become more complex and more fully featured, that ensures that the system that we're building is providing value, right? For example, if the requirement is having a web server, a test that shows that Apache is running correctly on the system shows that the system is more likely to be a web server than when there is no Apache running, although we expected that, right? The next thing I want to talk about, some of you, if you have worked with Puppet, already know this, but I think it's also a good refresher to frame the rest of the conversation is idempotency, right? Idempotency means that actions can be applied any number of times onto a system, but won't change the state of the system on subsequent applications. For Puppet, that's very convenient because specifically it means we can take the catalog, the desired state that Puppet that we have encoded for Puppet to run, and we can run that over and over again. And other than the first time when we enforce that desired state, there will be no additional changes happening to the system until we change the desired state or the system has drifted from that configuration, right? But in the regular operations of a system, there will be no ongoing churn on the system. So that's a very foundational property of Puppet system management, and only very few cases are where specific details are violating that principle, and they usually come with big red flags that somebody is doing something outside the safety of the usual system. Much of Puppet's ecosystem today relies on a catalog's idempotency for verification, right? Like when we're running impact analysis in CD4PE, that only makes sense if the thing that is in the catalog is really what the state will look like afterwards. Otherwise, those differences don't make a lot of sense, right? When we catch errors in testing, when something doesn't apply cleanly, again, that's an idempotency violation because it doesn't reach that desired state. We recognize that there is a problem that needs to be addressed before we move on into production. If there are unexpected changes in production, that's a high value signal that something in production has changed outside of our control. Maybe somebody installed a dependency or a package that we wanted to have installed, or maybe an attacker has changed something, or just a rogue process that changed something that is under Puppet control. Either way, it is something that needs to be checked as a deviation from that idempotent desired state. Conversely, the assumption often is if the Puppet run doesn't change anything, the system is healthy, right? That's a quite basic assumption, but is that really true, right? Here, I have a quick example to have a thought experiment on that. This configures Apache to serve static content from a directory. Consider what common issues would have a Puppet run fail on this code. When typing it up, I actually didn't find a lot. I mean, it's well-tested code. It's been battle hardened. Puppet usually just configures Apache for that static directory. Apache starts and it's fine, right? One of the ugly ones where this can go wrong is when the Apache service fails to start because of a fatal configuration error. For example, if port 80 is already in use, right? And then the Apache goes like, hey, somebody else is using my port, I can't start. And with recent improvements around systemd and how Puppet is managing systemd services, actually Puppet can detect that at the time of the initial application and report back. And so this is actually quite an easy to detect situation today, and it will just come back with Puppet just tried to deploy Apache and it errored, and somebody needs to intervene there, right? This nicely lines up with what I explained just before on the idempotency slide. An error on the service resource triggers a fix in the code or in the deployment, or somebody needs to go in and take that VM out and replace it with one that is not broken or whatever, right? Like there is a problem in our system and someone needs to get in that's or a problem outside of the expectations of the code, and somebody needs to go in and fix that. As a side note, this kind of error is also really helpful because it's actionable, right? If the service doesn't start because of a misconfiguration, it is really something that somebody needs to fix. Compare this to heaps of system load-based alerts that trigger anytime the service actually gets used, where there's nothing to actually do other than check, yeah, well, actually the system is currently in use, so it's okay, right? Sorry. Let's make the situation a bit more complicated, and by complicated, of course, I mean more realistic, right? In this example, I've replaced the static directory configuration with a backend service, and for simplicity's sake, just a Docker container. I'm sure all of you will have their own examples on how that looks in your environment, be that a database in the background or an application server or 100 other things that could possibly be connected to actually form the service that is relevant to the business. Searching for the actual configuration error on that slide is not really the point. So I've already highlighted where everything started to go wrong here, right? Puppet will happily configure these two services, Apache and the Docker container, and they will never work, and they will never ever talk to each other. And Puppet will not report any errors from applying this catalog, because Puppet doesn't have that concept of, oh, Apache needs to talk to this backend service here, right? Like that's not encoded here, and it's really hard to do so at this level. Or maybe the SSL certificate of Apache has expired and Apache starts fine, but it isn't really serving any requests because no browser accepts that certificate. Or the Docker images configuration doesn't look at the port variable and defaults to something else. Or there is a firewall configuration that blocks the access between those two processes. Or again, I'm sure any one of you will have their own example of that one time when something went too wrong. And you notice too late. It's okay. Accidents happen, and we fix it, and we learn it. We learn something from them, and we move on. But can we do something better here? Can we notice earlier? And for years and years, even before Puppet, we have developed monitoring tools to live with that, right? Itzinga or Nagios before that. Nagios, I looked it up. First release 2002. We've been working on these problems for a while now, right? And the issue is that I see here is those monitoring tools are not integrated with system management tools. Like, sure, some use the Itzinga modules to push out configuration for services. Some might have a different integration into their monitoring system to link up the things that we configure with the things that we monitor. But all of that requires extra effort and is not aware of what's going on within Puppet, and takes extra delays and multiple systems to observe to understand the actual state of the system. Excuse me. A few years back, Mina Galic and I had a talk and blog post at the configuration management camp about how testing Puppet idempotency and monitoring are facets of a bigger effort to verify our systems. I don't want to go too much into the details, but if you squint just right, you can see that monitoring is system testing, and that system testing is always a kind of monitoring because it needs to observe the state of a system to determine if the test was successful or not, right? And with operational verification, I want to take this to the next logic, for me, the next logical step of what if a Puppet run could tell you more about your service's health beyond that a process successfully started, right? What if we could add a check resource into that catalog that right then and there checks that the configured web service is alive and kicking and returns the proper status from its health check endpoint? This check resource here, currently mostly vaporware, but we have good people working on actually implementing this at the moment. This check resource will make a HTTP call to the specified URL and report a failure if that request doesn't return to 100, or if the body of the response is not the specified JSON. This will run directly on the managed node at the time, every time Puppet runs, and thus provides an ongoing audit trail of that the configuration that Puppet deployed is actually working. This doesn't make Puppet into a monitoring solution, right? I realize that, but it will provide another system health data point closely integrated into the management workflows, right? It happens directly after the service started. We can say, well, immediately afterwards it worked. It broke afterwards because of something else, right? Or Puppet didn't manage to get a healthy service together. It is maybe something that we deployed through Puppet at this point in time. It shows up in your reports, and again, you have that integration of what did Puppet change in the system, and how was the health of the system afterwards. For the sake of brevity, the example glosses over a couple of details like resource dependencies. Sure, we can rely on recent advances in Puppet to execute in manifest order, but for more complex configurations, maybe the checks are in a different class and need to be properly ordered, that they happen actually after the service has been configured. The service might take a few moments to start up, so the check should be configured with a retry loop and a timeout, but those are implementation details, right? That for the conversation today, it's just that idea of Puppet can have a higher level understanding of the service health, even if a lot of the gap that we're covering here is then not really enforceable at the time of noticing that it's wrong, but just surfacing that information back to the operations team. And I'm only scratching the surface here. For example, what happens when this gets included in board plans for deployment steering? Maybe it only fails on a couple of systems. If it fails only on 1% of the systems, is that good enough to roll it out to the other 100? Or is that a reason to stop the deployment and isolate the failing nodes from the load balancer? Is this useful in your CD4PE blue-green deployment pipeline so that you don't rush out management change to thousands of nodes that actually produces unworkable systems, right? To figure these things out and have some practical experiments, we're currently working on implementing that in the Puppet Labs OPV repository. That module has already some design sketches on the details of what we think is necessary to put into these resources and how they are looking. And we're gonna start implementation within the next couple of weeks. We're definitely looking for early feedback on how this fits into your workflow and what other checks you'd like to see. Of course, PRs especially welcome, but really any feedback that you can post in the repository's discussion forums is highly welcome, right? We've already identified more work that's necessary for this for general consumption. One big one is if a naive implementation of the resources that I had as a prototype would present a notification that the system state is fine, which then implies a lot of churn in the reports. And we're currently working on also making sure that that doesn't happen, so that you're only getting notification when there's something wrong and not also when there's something okay. You can find links to that in the repository if you're really interested. But again, mostly implementation details. So, but where do we go from here, right? Like, I'm not done with that idea yet. Clearly, there's some work to make this fully usable, and I've listed a couple of points here, like more checks. HTTP is nice. HTTPS with SSL cert verifications is an easy goal. PowerShell and running commands for arbitrary shell checks. Somebody please make a checkmk plugin. I would love to see that from somebody who actually knows what they're doing in that regard. Apt update to check for the mirror being up to date and apt update actually running, or no security updates outstanding. Certificate checks for certificates on disk as opposed to certificates that are exposed on a service. A service check that the service has actually started. I guess, again, with systemd, that might not be as important as it was a couple of years ago, but also it's not that hard to implement, so let's have a try at that. And then DB connections for Mysql and Postgresql. And again, whatever other ideas folks are coming up with, I would be very interested to hear where you see that being useful. And also, I mean, I have to admit, while I'm very excited about that, we don't have infinite budget, and I'd much rather see us implement checks that folks are actually asking for than things that I pull out of my hat. Yeah, fix reporting, I mentioned that already. The fix is about to land. As anything touching the low-level Puppet APIs, that was a little bit more challenging than I expected, but the the folks working on that did very well in knocking it out, and so that will be available in the next Puppet 6 and 7 releases likely. So that's a little bit of a bummer in that regards, but it's also just the reality that we have to work around, and that's that. Next on the list, exponential retry params. I think there's pretty well-established algorithms for exponential backoff with timeouts and jitter in there. So we just need to find the time and actually implement it. I don't think there's anything controversial in that one. Integration into existing modules is a point where I would certainly also love people's feedback. We at Puppet, we support a lot of core modules that deploy specific services like Apache, App, Mysql, Postgresql, just to name a few. And if you configure something, we should also prove that it works afterwards. So like in the example I showed, configure a vhost, make a connection to that vhost to show that it's available. I would be interested in what your all opinions are about that. Is that something you would like to see? Do you think that would be extremely awful because your local node never can connect to itself? Yeah, please let me know. Then, of course, the resources as they are written at a basic level can be used in bold plans in the apply blocks. But I'd rather maybe it would be more ergonomic to expose them as tasks and functions so that they look more native to bold. And the verification code itself is not very complex, so wrapping it in different calling conventions is also not a big problem. It just needs to be done, and I just want to mention that we have that on the roadmap. And finally, did I already say that? Please do throw any and all feedback that you have at us. The discussion forums on the GitHub repository are the best way. If you have a Puppet production environment, I would also appreciate any volunteers for a 45-minute in-depth UX interview where we can cross-check some of our basic assumptions and learn more about how people in the field are using CI/CD systems and how that would fit into their workflow. When I show this around internally, I usually got asked one or both of the following questions. First, when can I get this? And yeah, we're working on that, right? And the other one was, how does this interact with acceptance testing? And I'm glad you asked. This is, again, the example from before, a little bit restructured. And this configures a vhost, adds a file, and I'll check that that file is available on the web server. And this is now also an acceptance test case. If the file can be downloaded from the web server, the configuration is acceptable, right? Like it did what it's supposed to do. It has verified that it's within the specification of, or within the expectations of what we expect from the code to do. And let's be honest here, this is a more valid and more in-depth checking test implementation than most I've ever written at Puppet and before that, because it really checks the availability of the service and not just the idempotency of applying that basic configuration. Plugging that into Litmus or Beaker is quite straightforward using an idempotent apply method and just run that example on a provisioned node and see if it passes, right? The check resource already does all the checking inside that application. And if it has configured that Apache and it has downloaded that test file from the vhost, yeah, done, it works. And we know it works because we actually made a connection to the web server and have proven that it works. So, and notably, one of the big advances that is one of the main motivations of starting all of that, there is no Ruby involved in doing that. I mean, yes, today you need to have some boilerplate to have the test case with this string inside it and apply it. But really, it's not a big step to thinking of having a set of these files that are test cases in a special repository and having a tool that takes each of those, gets a VM, applies that, checks the result, and reports back the results without any involvement of Ruby, RSpec, RSpec Puppet, ServerSpec, or any of the other things that for people that are not developers are usually not great experiences, right? But wait, there is more, right? This is also a piece of the documentation for the Apache module. This is how you deploy Apache and configure it with a vhost that hosts static files. Taking a leaf out of behavioral-driven development tools like Cucumber, this is a behavior specification, right? Like add a couple of sentences at the start about how this is the way to configure a static vhost, and render it into a README or a reference, and you get a narrative a narrative documentation on all the different ways in which a vhost can be used for a static thing, for a proxy, using authentication, etc., right? Each with its specified check parameter or check resource at the bottom that makes sure that when we change the module, all of these different ways in which it can be configured still work. I know I don't know about you, but for me that sounds that makes me really excited. And then also, like, this is a unit test case. It might not look like it, but if this compiles, it means that the internal structure of the Apache vhost and everything fits together and works on various platforms and is using the right facts, etc., right? In this case, there's no data transformation, and the actual file deployment is better inspected at code review time 10 in a unit test. But for this basic example, that compile test is also really sufficient, right? In the bigger thing, in the bigger picture, there's one thing that we should be really unit testing, right? If you push that HTTP check at the bottom here into the vhost define itself, because as I was talking before, the vhost should actually make sure that it has configured itself correctly. The thing that we need to unit test is if we configure the vhost for a specific port, does the check actually check the right URL on the right port, right? This is the one unit test that's absolutely necessary to make sure that an acceptance test that tests that the check resource is working is actually testing the thing that was just configured, and it's not going out to Google and saying, oh yeah, I just configured the vhost and Google is accessible, right? Like that would be a nasty oversight and would make the acceptance test invalid. But with a small unit test to make sure that the configuration information is passed correctly to the check, we can then use that as a foundation for the acceptance test to be really, really accurate and valid, because we have already proven that the check resource will test the correct thing. Even further in the future, here's just loose and fast example to spark your imagination while still fitting everything on a single page. A bold deployment plan for a fictional application that has a database and an application server. In the first step, there is that apply block to deploy and configure the database on the DB server. And then it does a check that that application worked fine and that there were no errors there. Then there is an apply block for the application server to first check if the database is accessible from the application server, right? Like, important. If you can't reach the database, there's something wrong. And this then running on the application server can check the entire end-to-end chain of all the firewalls and networks in between, access rules, etc., etc. I skipped credentials here, but that's also something that could potentially be passed through here. And then if the database is accessible, it reconfigures the application server to use that database and be accessible on a specific URL. Again, the example is entirely hypothetical. I didn't even try to see if that is valid syntax, but I believe it is mostly. And then at the bottom, we again check that the application went correctly with check resources inside that app class. That already gives a high degree of confidence that the application is correctly configured. But at the end, another check HTTP call, this time from the node running the plan and not one of the configured nodes, to see if the application is available externally, right? Surely production systems will have additional complexities, like running database migrations, pre-configuration, post-configuration, quiesce the database and take a backup while running in a special mode, switch the app into and out of a maintenance mode. I think Nextcloud, for example, is very keen on steps like that. Draining, disconnecting, reestablishing load balancer configurations, configuring cluster members across multiple nodes, right? Again, I'm sure you all will come up with much more interesting examples than this one. But by virtue of having these critical checks directly where the configuration happens, they will not get lost in a shuffle, right? You use that deployment plan to deploy into your staging system. You use that to deploy into your development system. You use the same checks over and over again, and you can use the experience that you gain in your development systems and in your staging systems, that when the time comes to take that plan to your production systems and do a system upgrade or deploy a new database cluster member or whatever is actually encoded in that plan, it will run the same checks at the same point and will be able to catch that 1% of difference between your production system and your staging system at the time when it's running the deployment. And hopefully the hope is catch it before it starts destructive operations, or at least notifies the person running the plan at the time the plan is running that something is going wrong, and you can immediately react to that and start mitigation steps. Yeah, and that's all I have for you today, right? I hope I have inspired you to have a new perspective on testing and monitoring and how all of that fits together. And I hope you go and check out that OPV repository and drop us a note in the discussion forums on what you think of that and how that fits into your workflows. Michael, I think we still have a few minutes for Q&A before we maybe go to other topics. So I'll leave up the links here for reference in the background for now. And I'll also post the slides as a PDF with a mostly accurate transcript of what I talked about afterwards. And hopefully that can be distributed around.
Yeah, thanks. I'll be looking at that to the blog post I've been trying to transcribe right now. That was really interesting. I'm just trying to think of a question I had. Do you think the current method, and this is like stealing the question from Niklas, I think, does the way apply to Puppet only, or could it be like when I say I have my infrastructure as code tool, I have my monitoring in place? Is that something I could potentially use if I'm outside of the Puppet ecosystem?
I think the concepts do apply, right? And I've been when Mina and I were talking about our talk a couple of years ago, and yeah, the Hitchhiker's Guide to Testing and Infrastructure as Code, there is the link on the slide, and again in the materials afterwards. We did very much talk about how having your Isinger tests or your Isinger monitoring report back the status of your staging systems is part of understanding whether your deployment has worked, right? Like it's not it's not qualitatively different from what we've been doing since 2002 when Nagios was founded, or probably before that, as people had their shell scripts and Perl hacks and whatnot to understand, to get an overview of how their system was living. The difference is in the integration and moving it just that one step closer to the point of operation, right? Like you could equally have a shell script that deploys your thing, and at the end have a loop that polls for Nagios or triggers a check in Nagios and then polls for the result, right? Like the concept is exactly the same. Figure out at the point of deployment, what is the health of my system? And load balancers do that already just in their default configuration. Like if you configure it correctly, you can't hook up a backend to HA proxy if its status API endpoint is not healthy. It's not any different conceptually. It's just where do you put it, and when is the information accessible to the person who just made a configuration change?
Yeah, that's a really good point, because I was also thinking, why would I need to add an additional layer of a monitoring tool when the deployment process can already take care of it? So as you pointed out, you've been adding the check HTTP, which is it a function or is defined resource or something like that?
Yeah.
I think I've been using that in the past because I was like using Puppet to provision Elasticsearch, and I needed to wait for the REST API to come up, which takes a while. And then I wanted to provision some Kibana dashboards or something like that, as far as I know. And at first glance, I wrote my own bash scripts, and I'm not a fan of bash scripting. So I made mistakes, and this took me longer than I anticipated. So I was really happy to see that this was made a resource. The thing is, like having a health check, this is similar to Prometheus and having like the black box exporter or the ping probes or something else. Is there a concrete plan to add more of these health checks? So you had a slide with next steps and what's needed, and this was quite a lot to unpack. Is there a current discussion of saying, hey, I want to add, for example, check TCP as a resource, or check, doesn't need to be a check, could be like a probe or a health thing?
As I said, I'm currently at the very start of this project, and we've been discussing the idea internally, and I think it has legs, and it's something where we can I don't want to say rip off, but package existing practices into a better together solution, right? Like Puppet in its core is a integration solution and not a do solution, right? Like the example that I always use is Puppet installs packages. Puppet does not install packages. Puppet lets you install packages. Puppet uses the package managers to install your packages, right? And implementing the checks here is a little bit in the gray area beyond what I think Puppet is really comfortable with. But on the other hand, it provides a starting point for the conversation. It gives people that mental framework of, oh, hey, I can get my feedback earlier, right? Like I can get my feedback during deployment, not 20 minutes later when monitoring alerts me. I can get the feedback during my tests without having to write Ruby instead of during deployment, et cetera, right? Like I think it's a lot of people have suffered a long time by test tooling being very developer and specifically software engineering focused, requiring Ruby, requiring server spec or other really programmy methods. And again, as I showed in some of the examples, if you can read and write Puppet, you can read and write a test case here. So making it more accessible to people to have this kind of feedback earlier in the process, and therefore making the end less surprising. That is really the goal here.
Yeah, I keep thinking. I was reading the Prometheus Up and Running book lately, and I think there is an exporter for literally everything you had on the slide and beyond. So like having a node exporter or like black box exporter or whatever is needed, and exposing an HTTP endpoint, and you deploy, for example, the Docker image with Puppet as part of the infrastructure as code process, you could spin up like a metrics endpoint on the host in addition, which probably means you need to create the check HTTP, but ask the Prometheus resource or the remote resource. You don't need to have a Prometheus instance somewhere. This is like away from the monitoring. The idea would be like you have an EC2 instance, you use Puppet to deploy it and install Nginx or whatever. And as a sidecar container, you install a Prometheus exporter, and you use that as a health probe endpoint, basically.
Yeah, I think there are getting the basics right means it will open a lot of possibilities down the line, right? I don't think, as I said, I don't think this will make Puppet a monitoring system, but like you said, it provides the stepping stone to integrate with a monitoring system.
The thing is, because if you start adding more health checks on your own, you're probably reinventing the wheel with the database connection, with an HTTP connection, certificate handling, whatever. And like using what's already there in this open source could be a way of saying, hey, we are bundling something, or we're using existing resources, and you get it out of the box. If you want to integrate with like Zabbix or Sensu or whatever, here is a different way, but out of the box you will get that. The thing is, you probably could do it on your own and write your own simple interfaces. In my experience, and I think we made a mistake in Singer with adding too many functions, at least in the Singer 2 in the DSL. We wanted to add everything. We wanted to add embedded database checks, embedded whatever in C++, which made our code not really approachable, and contributions were impossible because there were just 3 people understanding it and nobody else. Yeah. So like having something open where everyone can contribute, okay, sounds odd, but still would be a good idea. I'm just not sure if
I think there is a certain tension there. Like, of course, I'm going to of course the OPV module will be open source. And I would love to see more people contributing checks and improving what can be integrated there, right? Like integrate a check Isinga that goes out to Isinga, triggers a specific check, and then waits for the result, right? Like I think that would be entirely possible to implement. And in Ruby, it's not impossible, right? The tension is, for a lot of our customers and a lot of people using Puppet, writing Ruby is outside the day-to-day work and just not on the personal roadmap of a lot of operations people out there. That's just the sad reality of life in the enterprise.
Yeah, you need to find abstractions, and you basically need to hide it. And probably if, for example, you're taking the route of adding a Prometheus exporter, somehow you would totally hide it away and say, hey, this is like my health probe, which gets automatically deployed, and in the background it's a Docker image which somehow lands on the host. But as a consumer or as a customer, I don't care about it. I just want to see, hey, the deployment worked, or hey, it's slow because the
You would be
configuration
surprised.
for the buffer is wrong.
You would be surprised how many people care about the amount of agents deployed on their systems, right? Like,
yeah, that's also a story which can get quite long. I'm also thinking about when you're deploying it in your Kubernetes cluster, for example, you probably want to have something. Yeah, okay, well, you're probably using a different method then. But it's a similar thought in a way of saying, hey, I want to have a health endpoint. I don't want to like reinvent the wheel again.
Like if you bring up Kubernetes, where would Puppet run, right? Like Puppet would not be running in one of the containers in a pod as part of your application. Puppet would be running outside of Kubernetes itself and configure specific things in the Kubernetes API or take care of managing the base Kubernetes installation. And there, the question then is, for example, if you configure a ingress server or do a network configuration change, like, sure, suddenly you have, again, something that you can verify. Oh, is my network configuration change now actually working? Is that ingress server now providing the right connectivity, et cetera, et cetera? Is the Helm chart that I just rolled out into that cluster responding on, again, on the health status API that is implemented in the application with the correct data?
I think, yeah, I forgot that Puppet uses an agent for deployment. I'm living too much in the Ansible world, I think. The point you're making is like Puppet manages the outside of the Kubernetes cluster, and the deployment happens whatever with CI/CD or something else. You have a very good REST API to consume, and you can basically build a Kubernetes integration based on that API because everything is already there, and you get the status information whether port 80 or port whatever is bound to that, and the application works, which potentially makes it easier for you to integrate because you don't need to add any health checks or write too much Ruby code. But for like bare metal or virtual machines, What are the? I'm talking too much. What are the others thinking around this topic? Or maybe sleeping. I have no problem. I can talk all day.
Just call them up one by one.
Yeah, one by one. Hi, Niklas. Are you here? It's a little awkward. Am I muted? No. But maybe you can stop screen sharing so we can open up the discussion round.
Sure.
David.
Yeah.
Nobody wants to talk.
Okay, unmuted.
I have to be honest. So I'm from the Windows world. So I know that Puppet is restricted in the Windows world. So it's not.
The agent is fully supported on Windows.
Okay, so then it's pretty interesting because I have no virtualization or something like that. So this could be pretty interesting to bring into my systems.
Completely unrelated. Also, we're currently in the final stages of wrapping all the DSC resources in Puppet code so that you can get all the fine-grained property by property change reporting from Puppet, but based on DSC resources. So if you're more familiar with PowerShell or something like that, but not happy about their deployment model or their reporting, Puppet can do better.
So I'm not the PowerShell guy. I'm the command prompt guy. But sounds pretty interesting. So I will have a deeper look into the system.
I
always thought that there are some restrictions in the Windows world. So this is pretty interesting now.
Yeah, Puppet was, I think, a sponsor of Chocolate in the first years, or at least the maintainer of Chocolate worked at Puppet on Puppet for Windows. I think Fairfield Coder was the name or the handle.
Rob Reynolds, he's the founder of Chocolate.
I met him at a Puppet Conf some years ago, and was excited to learn. And I think Puppet with an agent on Windows works pretty reliable in contrast to like finding a way to SSH into Windows. It's better now, but if you need to maintain something older, which you need to like manage, it gets complicated without an agent. And NuGet or whatever package manager is the hot shit now. I
think
also
Windows is suffering from not having a native package manager, and from what I heard from the Windows folks, their rollout of the last try of WinGet, or what it was called, was not well received, as they still don't get community fully.
I think that's pretty hard to get this, because so many friction in the ecosystem. So I'm hoping WinGet will win, but I don't think so.
Yeah, but we're digressing from the actual topic, like integrating that in your workflow. Do you think that that could help, or do you think the concepts make sense, or am I completely off base? Come on, give it to me.
So for my case, I think that this is a really viable option for me, because I sometimes have to reinvent the wheels, and I don't like that. I have to write my own system to get some checks. So this could be really a viable option for me. So I think I couldn't speak for everybody, but I think in this for the Windows enterprise business, I think this could help a lot.
Do you have a monitoring system in place?
Right now, a custom one, because we have so many special requirements that we couldn't fit an existing one. But now maybe I have, when this is done, or at least I can test it, I will give it a chance and see, because I always have to write my own request solution, ping solutions, because nothing really fits well into the Windows space. So there are solutions, but sometimes they are so expensive that afford it is not so easy. And this one seems to be much smaller, but much more targeted.
Yeah. And I don't know if I mentioned it in the talk itself, but like nothing keeps you from running your check resources on a different node than the thing that you're checking, right? Like,
one use case I was thinking of, when I'm managing everything in Git and then using CI/CD and triggering a Puppet run, and then like the catalog or the agent pulls everything, I could use Bolt to immediately execute something, and potentially get immediate feedback. So I can like integrate it in my GitLab dashboard, for example, but also use Puppet. Is it the enterprise console, or like the front end, to see the current state? And specifically, a use case of mine is always I'm deploying websites or then deploying something, and I want to ensure that not only the text or the color is right, but I want to see that a certain end-to-end test that when I click on a button, that something moves out or something happens. And having a more approachable interface. I'm not a fan of diving into ASPEC and accessibility testing and everything else and understanding it. I would love to say, hey, please test this, and this is how it looks like now, and this is like this is the expected picture which I'm uploading now. This is my test, and if it doesn't look like that, taking a screenshot, roll back automatically. This is an enterprise feature, or like warn me about it. This would be awesome.
I think there are web testing solutions that already give you that, right? The question is, how do you set them up and how do you integrate them in your workflows? And having a check resource that kicks off one of these tests, yeah, maybe not. If you're really in-depth testing your web application after you've deployed it, you probably want to go for a real solution like Selenium Grid or something like that. And okay. Probably people who actually do web testing will hate me for saying that, because I heard some people be very unhappy about Selenium Grid, but like the options are out there. And
okay, yeah, it's just one of many examples which we have already.
But yeah. But to your actually Puppet related part of that question, I just talked to somebody who has a lot of clients who are using Puppet in quite regulated environments, and an interesting thing is happening there, that they're mostly focused on managing the baseline of the system in an iterative, in an ongoing state enforcement way, right? And that is managed by one team, and then it sounds like actually the actual application that's deployed on there is not as relevant to that system baseline, right? So certainly I see a future where you have a core infrastructure team running the Puppet agent on all the systems, taking care of the system baseline so that it's still CIS compliant, so that it's still PCI DSS compliant, so that all the security stuff runs on it. But then the application gets deployed through a bold deployment plan that doesn't actually have regular state enforcement, but it just deploys the files, starts the service, configures a couple of things, make sure that everything fits together, and hands it off to a different part. And that bold deployment plan then orchestrates across the entire cluster or parts of the clusters and does rolling upgrades or whatever else is needed for the cluster, or goes back and forth between nodes to check the health of the things. And then again, going back to your pipeline example, yes, you have your complete pipeline then starts with some unit tests and syntax validation because they're cheap and easy and fast, and then goes on to I get 5 VMs from my vSphere cluster. I chuck out that deployment plan against those 5 machines, and it creates a service that goes green, and it goes on, and then it starts a Selenium test cell that connects to that application server or that web front end in that cluster that was just stood up, and checks that everything there is okay. And then all of that gets recycled into the digital void, and it's ready for an approval or for waiting for a maintenance window to run the same deployment against a production version of the cluster. Maybe then with 50 nodes or whatever, right?
Yeah. Thanks. I think it's deeply tied into what we've been discussing with quality gates and Captain and Cloud Native and SLOs and application performance monitoring, like not only defining the health in a way of this is a state, but like the performance, the CPU usage increased and the memory usage increased by this commit or by this change. It's technically not related to infrastructure as code, but this could be like you don't want to maintain different workflows for just one thing. You want to tie it deeply, and I'm just thinking Puppet could act as a quality gate as well, having all the information, right?
Yeah, sure. Like if you can't deploy it, what is the code worth?
So we could tie Captain with Puppet, or take the idea of Captain.
And there are more possibilities with Bolt, right? Like one of the things that I always wanted to implement but never got around to is every database management system should come with a Bolt backup task and a Bolt restore task that you can just point at your configuration data for the database and say, well, I've configured that database, now run a backup for that and pull the data, that backup down to this location. And conversely, since the code knows all the details of where the database is configured and where the backups are configured, now I can go back and say, execute this task to take that backup and restore it back into that database or a new instance that is adequately configured. And then for our enterprise customers, all of that would run through the console and be adequately audited, et cetera, so that you can see what happened while you were offline or things like that, right? But yeah, finite budget.
Next week is SLOconf. This would be a great additional topic in the short amount of time. Yeah, I think there are like good possibilities and obviously endless possibilities making our lives easier. Is there? So I have the GitHub repository opened. Is when you say you want feedback, is there like something where you want someone encouraged to contribute or create code?
So if you look at the issues on the repository, there are a couple of ones that are tagged as enhancements. I've pretty detailed fleshed them out, ready to be implemented as soon as the team gets ready for it. But certainly, if anybody wants to get involved, again, drop in the discussion forums on the repository and have a chat of what you want to do and how you want to use it. I think at this point, it's a little bit early to start slinging code. But on the other hand, hey, I'm not going to keep you from it. I just can't promise that anything of this goes anywhere as our understanding progresses of how the things are useful in the Puppet ecosystem. But then
so
somebody from the community who says, hey, they're using this in production and it's awesome, even when it's a pre-release prototype, gives me much more legs to stand on and argue the case for this work than anything else that you could post in a discussion forum, right?
It is true. I'm just trying to make people curious on how to get started more easily, and just like finding a use case. And probably we have many use cases where we deploy something and it doesn't work afterwards, and then we spend 10 hours of debugging and pair programming and finding out that it's just one by one offset, no, by whatever offset. But yeah, the point is, finding a use case and trying to solve a problem and trying it out is, I think, a great idea. And maybe we check back in half a year or in some weeks and say, hey, David, did it work? Or what's the new system? Oh, just kidding.
Yeah, no, I'm looking forward to that question because I'm already very interested in how it will turn out too.
If I want to look into the code, I need to understand Ruby, right? Yeah.
Yeah, that is one of the limitations. The lead for the DSC work, as soon as he's done with the DSC work, he already is talking about, now that he understands the infrastructure better that he's been working on, he wants to do native PowerShell providers so that for Windows people like Michael, you can then implement your provider in PowerShell without having to touch Ruby, and it will just natively integrate in Puppet. I think that too would be a great addition to our arsenal for improving, for continuing to improve our Windows story.
Yeah, I just, and this is not on the recording, but I will add it to the blog post. I just checked the code of the check HTTP check command thing. it looks rather straightforward. So
yeah. And again, like this is currently just a prototype that I scratched together to start my understanding of how it could work and how it goes together. And for example, one of the things that I noticed really quickly is that reporting with a change notification that everything is okay is really awful. so we're fixing that as a first step. Because again, as I talked about in idempotency, people expect that nothing means no news is good news, right? And then saying, oh, hey, here, something changed. The service is still running. No. No.
And I think one of the challenges which will come up is like, I need a history to verify whether the system is healthy. So I need the last 10 checks or the last 10 deployments so I can say, hey, this works somehow. And then you need a backend to provide this data and like talk to a TSDB or a database or exported resources or whatever is like needed for that.
Yeah, there are of course a lot of options, but since I'm currently paid by Puppet, I have to point out that Puppet Enterprise gives you an archive of all your reports for a node where you could look up that data, as well as the APIs to do reports on that.
Yeah, I was just thinking about that. So you have like the ideal world or the better world of saying, hey, I have that already. I don't need to invent it right now. Because yeah, I think it's a great initiative and a great project. I would need to clone myself 10 times to contribute. I'm hoping that everyone else steps up. No, let's see about it. I think it's like keeping the pipeline idea in mind and deploying things and making sure it works sounds like a really nifty idea. So I really like it. Yeah, and I would say thanks for the presentation and the discussion today. If there are no further questions, I would close with the typically buy on YouTube.
So one thing. So because it's the first anniversary of Everyone Can Contribute Coffee chat, so I just want to say for me and for all the other people, thank you, Michael, for bringing us all together in this really awesome way. So that's why thank you, Michael, is there. And hopefully we have another year and multiple ones to bring us all together to learn such cool things like this Puppet thing from day to day. So thank you a lot for this.
Thank you. And now you need to pose again for a screenshot. Thank you. Yeah, it's the pleasure is all mine, and you've seen all the Twitter notifications you got today. I think we're learning a lot, and we're, I think, like meeting each other at some point in person, hopefully, is the ultimate goal. And travel the world and enjoy what we're doing. And I hear you're using a custom monitoring system. I think I need to travel to Lower Austria and fix that problem.
No problem.
I also said that that was last Tuesday at KubeCon EU when Dynatrace said they're not using GitLab yet. So I'm traveling to Linz and fixing the problem. For next week, I thought we could be looking into K-span, which is mapping object relationships in Kubernetes to tracing. I don't know if we find the time to do it, but it was one of the hottest topics last week at KubeCon, and the tweet was like going a little wild. And it's just an idea, so we can like decide short notice. After that, I was in the AWS user group meetup on Monday for Nuremberg, and I met Chris from AWS, and we thought about machine learning. And this is like the spontaneous idea for the week after the week. Just need to check our events page. I'm a little exhausted and tired this week, so thinking in German and translating live to English. Yeah, and then June 2nd, Frederick joins from Polar Signals, talking about continuous profiling. This will be super interesting, I think. The week after, we dive into Snyk with Matt. And I've also asked Anais, who recently joined SQL Cloud. I hope I pronounced that correctly, or CyberCloud, which is a new Kubernetes cloud hosting or offering, or K3S, I think. Yeah, I said we're curious to learn. So yeah, this is like the plan for the coming weeks, like doing a little more than Kubernetes and learning new things. Everything else afterwards is still free, so pitch today and benefit tomorrow. Ooh, marketing works. No, just kidding. If we find any topics or do it spontaneously, everything is good. Yep, and yeah, thanks again, and have a great rest of your week. And now I'm saying bye on YouTube.
Bye.